Welcome back, AP Statistics students. Mr. Eicher here, looking at 2020 mock exam number 6. Big shout out to my college buddy, Joel Cam. We roomed together at the AP reading. Great to hang out and chat. Basically, just imagine rooming with a really good friend over 7 days where you get to grade a bunch of AP Stats exams, and every evening, right before falling asleep, you get to talk on and on and on and on and on about statistics. It is just wonderful. But thanks to him for some of the ideas of this first question. A couple edits from from yours truly. But this is the 25-minute question. Clock will say 30 minutes, and then after 25 minutes, it'll turn red. There will be no sound, so you got to pay attention to it. It'll turn red, and then you do your upload. Make sure you're thinking through the process, how you're going to do the upload for this year's exam. But this question came from the, let's see, I think it was the 2015 or 16 AP exam. I have to double check. But it was question 5 on that exam, whichever one it was. So we have 2 statements. We have a random sample of 1,048 adults in the US. And we're given the breakdown of how many said environment or economy or no preference. And question A, now on the original exam, it had students construct and interpret a confidence interval from scratch, but since this year's AP exam is calculator light, decided to kind of rewrite it and give you the margin of error and see what you can do with that. So for a confidence interval, every confidence interval is basically a statistic plus or minus a margin of error. Margin of error. So if you have the margin of error, you just need the statistic, and the statistic for the economy statement is 37. So we have 0.37 plus or minus 0.04. You definitely want to show that work and then do a little calculation. There it is. Now, it's really common for students to move on from there, but notice you need to interpret the confidence interval. That's something that you can be considering. If you do have time left over before submitting your test, I would double check. Did they ask me to do something that I forgot to do? Did I interpret everything they asked me to interpret? This is really common to forget on questions like calculate and interpret a residual. Since it takes several steps to calculate a residual, sometimes students will get the answer and move on and forget to interpret the residual. But here, our interpretation, we have 99% confidence that this interval captures the unknown population proportion and then context of all adults in the US who would have chosen, that's an important word there, who would have chosen the economy statement. You don't want this to be past tense. Avoid past tense. If you say something like captures the proportion of adults who said economy, that makes us think as readers that you're referring to the sample that was collected, but we want to know about the population of all adults. So careful about your wording there, but that would be the answer to part A. Scoring for something like this, to get an E, you'd obviously need to get the interval correct with work. So work plus the correct answer. You'd want a statement. You want to convince us that you're talking about the parameter. You can do that a couple different ways. You could say unknown proportion or population proportion or all adults. Those are all ways to convince us that you're talking about the parameter. You need to have context. And you'd need to mention your confidence level, 99% somewhere in there. Not 95, but 99% confidence. Question B was on the AP exam too. And this is a good example of why a condition matters. One of the conditions for inference is that the number who choose the economy statement and the number who don't are both greater than 10. So this is the NP greater than 10. And N1 minus P is greater than or equal to 10. So why do we check this? Well, as you can see, here's the official solution from College Board. The conditions necessary because the formula for the interval relies on the fact that the binomial distribution can be approximated by a normal distribution, which then results in a sampling distribution of p hat being approximately normal. The approximation does not work well if both, or it does not work well unless both n and np and n1 minus p are both at least 10. And since we're doing an interval, I should update these with p hats. Now that's a really sophisticated answer. Did you have to say all of that to get full credit? Well, let's see. Oh, I guess I'll wait. But no, you did not have to say all that. We'll come back to that once we score this. This part was scored with a later part. So after we do part D, we'll refer back to that. But maybe I'll just draw you a little picture. With binomial distributions, if you think of a histogram, if you have a very low p, a very low sample size, then you could have a binomial distribution that looks like this. A binomial distribution, though, will be approximately normal when n times p is greater than or equal to 10, and n1 minus p is greater than or equal to 10. So then your binomial distribution would look like this. And then you can use a normal approximation. But we'll talk more about that after part D. So I snuck part C in there about other conditions. This other condition is about random selection. Explain why that's necessary. And I gave you two reasons. You don't need both. So you could have an E if you said something like this, or you can get an E if you said something like this. I don't think the AP exam would require both of these to get an E, but hopefully you said one or the other. So first, we'd like to infer to the entire population. And to do so, we need to make sure our sample is representative of the population. So that's why we select a random sample to get a representative sample. Another reason, we'd like our statistic to be an unbiased estimate of P, right? If we don't take a random sample, like if not random, then what? If not random, what's going to happen? Are you just going to do like a convenience sample? Well, that's going to lead to biased estimates. Convenience samples are not representative of the population. So in order to have an unbiased estimate, we need a random sample. So that's why random selection is important. Now, if this had been an experiment with random assignment, we would mention inferring the treatments were the cause of the effect, the response variable. All right, and then D, a suggestion was made to use a 2-sample Z interval for a difference in proportions between those who would have chosen the environment statement and those who would have chosen the economy statement. Is this appropriate? Is the 2-sample Z interval appropriate here? Justify your answer. And the answer we would say is no, it's not appropriate, because one of the requirements for a 2-sample Z interval is to have 2 samples, huh? Yeah, what do you say? It's based on 2 independent samples. In the situation described, we only have a single sample. So they are not independent. If someone chose economy, that tells you that they did not choose environment. So if you said economy, environment is not possible. That means they're dependent on each other. We do not have 2 independent samples, but 1 sample. So like I was mentioning earlier, part B and D were scored together. So to get an E, full credit, you would have to meet these 2 parts. Part B states the condition implies the sampling distribution is approximately normal, or that the normal approximation to the binomial distribution is appropriate. I'm guessing you said something like that first part. Now, if you just said, yes, it's important because roughly normal, then you would not get full credit. You had to say what distribution it is. Now down here it says, you could say the sampling distribution needs to be normal without explicitly mentioning which statistic it is. So they were gracious about letting students say, yes, this is an important condition because it makes the sampling distribution approximate normal. But technically it's the sampling distribution of p hat. And then part C, really this for us is part D in this reworked problem. Part D indicates the procedure is not appropriate because two proportions come from a single sample rather than two samples. And I do want to mention, it's not listed here, but I do want to mention that this is another case where the two samples versus the one sample. This is another case where you want to explain, to get full credit, you had to say, no, this is not appropriate because we would need two samples for the two sample z-test for difference of proportions. But we only have one sample. It wasn't deemed enough communication, enough clear communication that if a student just said, for my part D up there, no, we need two samples. That doesn't apply like was it originally three samples? And you say, well, no, that's not appropriate because we need two. Like we need to know what it was and what you need. So some students said, no, we have only one sample. And the problem with that, I mean, it's not entirely wrong, right? But the problem is, what do you need? Do you need three samples? Do you need four? Do you need five samples? Like, what do you need? You need two samples. So it's really important. Like I've said many times before, whenever you're, trying to argue for something, to give like a pro and a con. So I guess in this case, the positive would be we need two samples. The con is, well, we only have one sample, so it's not appropriate. Okay, so E, I've given two different ideas of how to answer E. And I would think I intended this question to be kind of the, can I really set apart students who can articulate, communicate well, and who understand statistics really well? So like students who understand and get this question, they would be like the high five kind of students in my book. Hopefully many of these other parts you're able to get. But overall, this is a pretty difficult question, and students did struggle with multiple parts of this question. But on part E, the researcher wants the margin of error to be halved. So describe what could be done. Now, if you said increase the sample size, that's true, but that wouldn't get an E in my book. I'd want a lot more articulation and specificity. So specificity meaning you need to quadruple the sample size. So the question says, describe what could be done and a possible drawback of this approach. So like minimally, for full credit, I think I would accept, in order to have the margin of error, we need to quadruple the sample size. And then to address the possible drawback, which is right there. Now, what I've given, since we're in distance learning and not around, all this information I wanted to articulate to you how I know it's quadrupling. And a student who actually makes that kind of argument and knows the underlying reason why we need to quadruple, multiply by 4 the sample size, would be a very, very, very strong response. So you could read that and message me or contact me if that's not clear, why we need to quadruple. But a possible drawback is if you got a quadruple to have the margin of error, that's a lot more people. It's going to take a lot more time and more resources than the original 1,000 or so adults. Here's a other option. So this is like in and of itself, that stuff could get you an E. Here's a second way to an E. Rather than the sample size, maybe you said, well, you can change the confidence level. That's true. And a drawback of changing the confidence level would be, well, now you're going to be less confident. Now, I actually calculated, and I think if I wanted to make this like a really drop down, like you got to really know your stuff, I'd require students to give me a little bit more than just saying change the confidence level. Because specifically, I want the margin of error to be halved, and how much should you change the confidence level? So the critical value could be adjusted in order to have the margin of error. With 99% confidence, Z star is this. You could get that by using inverse norm on your calculator. And 99% would be 995. So that would be that. You could also use table A. So I think that's a fair question. And on a calculator light, still nothing too crazy calculator needed here. If we kept the sample size and sample proportion the same, then we would need a Z star of, here's our original. We want that to halve, so our margin of error halves. So now we need that Z star. And then working backwards, if Z star is 1.288, then we would have a confidence level of about 80%. And the way that I got that was by doing normal CDF. Here's my 1.288. That's the upper bound, the lower bound's the same number, but an opposite. And this area in here is what I just calculated with normal CDF. Or you could use a table to calculate that area. Now we would be able to have the actual level of 80%. But a problem with that is, hey, we're going to be less likely to capture the population proportion, going from 99 to 80%. So I hope that you thought at least to increase the sample size, and maybe you thought to change Z star in this formula, ultimately, the margin of error formula. So increasing N would decrease the margin of error, and decreasing or halving the Z star would also have the margin of error. And that formula is on the formula sheet. Okay, and then the last question. Researcher wants to do a follow-up survey of a randomly selected group of adults in the US. And in the previous, and so he proposes this question. In the previous study, we found that almost 60% of respondents believe the protection should be given to the environment over economic growth. Which statement best represents your opinion? Option 1, the environment statement. Option 2, economic growth. And my question is, what type of bias is likely to result if this question is presented to individuals in the sample? Explain what that would mean in this context. So I don't want you just to say like bias in the wording of the question. I want you to explain it. This is question wording bias leads individuals to agree with the majority. So ultimately, kind of priming them to feel bad about responding in a certain way. So the majority who've answered environment over economic growth, it's kind of a bandwagon, not that that's a specific AP stats term, but sometimes students in AP Gov, I think, or maybe psychology like to mention that term. But it's the bandwagon effect where people feel pressured to agree with the majority because they don't want to be seen as odd or different. So we would then overestimate the proportion of US adults who would choose environment over economy. So this is a type of not sampling bias, but non-sampling bias. A random sample is taken, so it's not a sampling error, but it's a non-sampling error. The wording of the question has led to bias, and then to explain that. Thank you for watching this video. I hope it was helpful for you. If it was, give me a thumbs up. And thank you again for all your hard work reviewing for the AP exam. Good luck.